Okay, today we're going to be doing our limiting reacting podcast, and so we're going to talk first about what limiting reactants are. Now, we talked briefly about limiting reactants when we discussed how many cookies you could make using a limited number of ingredients, for example. And so you'll see that come up again as part of an analogy. But first we're going to look at a reaction, and we have a reaction here that has nitrogen gas and hydrogen gas are reacting to form ammonia. So we are going to look at the nitrogen gas specifically. Suppose that we had 3 molecules of nitrogen gas. So that would be 3 molecules of nitrogen gas. And suppose we had 3 molecules of hydrogen gas. So just randomly in the air you have 3 molecules of each. And then we take a look at how much, or what would happen if these reacted. Now, according to our equation, 1 nitrogen molecule, that's 2 nitrogens, but 1 nitrogen molecule reacts with 3 hydrogen molecules to form an ammonia, or 2 ammonia. So if we take a look at what happens to these molecules, we're taking 1 of these N2s and 3 of these H2s, and we rearrange them to form 2 ammonia. Now, the problem with this is over here you have leftover nitrogen, but you don't have any hydrogen left over, which means that at this point the reaction stops. And why? Why does it stop? Why do we stop the reaction at this point? And the answer to this is there's no more hydrogens left. Now, if we had more hydrogens, then these nitrogens over here could react. But with the complete absence of hydrogen, because all the hydrogens have been used up in the reaction, then you end the reaction's over. Okay? So hydrogen is what we would call the limiting reactant. Okay? You run out of it and you're done. So, back to our original question, a limiting reactant is the reactant that limits the amount of product that you can produce. Okay? It limits the amount of product produced because it runs out, and when it runs out, the reaction stops. Okay? All other reactants we call excess reactants. They're leftovers. Okay? So what is an excess reactant? Well, an excess reactant is a reactant that does not limit the amount of product that you produce. For example, if we were to go back to our chocolate chip cookie recipe, one of the excess reactants might be something that you have in abundance, something that you have a lot of, like water. When you're cooking in the kitchen, water is not normally a limiting reactant because you can always get more. It would be an excess reactant. It's not limiting how much product you can produce. Okay. So if there's always some quantity of excess reactant left over after a reaction occurs. So you will always have an excess reactant, you'll always have a limiting reactant. Okay? So in order to calculate the limiting reactant, we need to use our stoichiometry, and I'll give you an example here. If you have 6.7 moles of sodium reacting with 3.2 moles of chlorine, which is your limiting reactant? So first we need to look at the equation, which would be 2 sodium plus chlorine gas will react to form 2 salt molecules. Okay? So in order to solve this, you need to be able to compare the 2 reactants to each other. And here you see that your molar ratio is 2 moles of sodium to every 1 mole of chlorine gas. So in order to compare these 2 reactants, you need to convert one reactant to moles. In this case, our reactant is already in moles. Both of the reactants are already in moles. And it doesn't really matter which of your reactants you do this with. We can choose to do sodium first because it's the first one in the problem, but you could just as easily do this with chlorine. Okay. Then you use your balanced equation to convert into the other reactant. You will convert whatever the second unit reactant is in. In this case, it's in moles, so we're not going to need to convert into moles or out of moles because we're just comparing the moles. Okay. Then you interpret your answer. This is where we're going to need to do a lot of practice interpreting what our answer means, and I'll explain that a little more in just a moment. Okay? The interpretation boils down to, if the number you calculated is greater than what was given to you in the problem, then the second reactant that you're looking at is limiting. If the number you calculated is less than what you were given in the problem, then the second reactant is excess. Now, this seems like a lot of rules to remember, but once you start working these problems, it will kind of seem like common sense. Okay? So let's take a look at how you would actually work this problem. We're going to start with 6.7 moles of sodium, because that's given to us in the problem. And we're going to convert this into how many moles of chlorine that would react with. And we use our molar ratio. Of course, our molar ratio here is 2 moles of sodium for every 1 mole of chlorine. So we put this down here with our 1 mole of chlorine to 2 moles of sodium. And this would mean that 6.7 moles of sodium could react with 3.35 moles of chlorine. Okay, so you know how much sodium would react with how much chlorine. So now is the interpretation phase of these types of questions. Now, if you need 3.35 moles of chlorine in order to react with our 6.7 moles of sodium, so that's what this is saying. But how many moles of chlorine were we given? In the original problem, if you come back up here, we'll see that we are given 3.2 moles of chlorine gas. Okay? So, do you have enough to react with the amount of sodium that you were given? So if we were given 3.2 moles of chlorine, we need 3.3 moles of chlorine. Do you have enough? And the answer is, of course, no, you don't have enough. We need more than we were given. That would make chlorine our limiting reactant. So if you can work these basic problems, if you can do basic stoichiometry, there should be no difficulty in determining what your limiting reactant's going to be. Now, we will do some example problems of this, both in podcast form as well as in class, but that is your basics of limiting reactants. So basically, you're looking for, what do I have less of than I need? What am I going to run out of first? Okay, so you're looking for what ingredients in your chemical equation are you going to run out of? And that's it on limiting reactants. I'll see you in class.